Thank you for the introductory and kind words. Appreciate this session and also the opportunity given from the Easy Council Global. Okay, I think people already know about me from that introductory. Let's proceed with our slide discussion. Okay. This will be our first introductory. Before I speak further about the serverless architecture, let me share a bit about this. The technology change actually faster than the most business can keep up with. The proliferation of the mobile technology, the Internet of Things, and the cloud computing has changed the type of the asset that connected to the network. Implementing the cybersecurity best practice across an increasingly unstructured, the keyword is unstructured here, and decentralized network is one of the most taxing challenge facing in a company today. So it's not about the structure, it's more about unstructured and decentralized. In 1990s, for example, later called as traditional cybersecurity, that time we know that as information security instead of cybersecurity because internet is not yet really familiar at that time. So the approach is revolved around the medieval concept, showing like on this slide, around the medieval concept of protecting the crown jewel as a concentric circle, a view of layer security focused on protecting the important data at the center to the successive layer of defense, such as application, the host base, the network, and then the physical control. So that's all that combined. And the defensive strategy works in a centralized control and managed device network, which has become increasingly extinct. So we are no longer see that. Practically, every company have the most common over device that they purchase, configure, and issue to the user. But now, as the consumer-driven technology drives the new device and the system, the organization are losing control over device their user and network interact with. They are losing the control. More often than, the company fail at deploying the traditional security control to the nodes connecting to the network. The keyword in here is manage the unmanaged. So things is coming through the network. Administrators say they know everything, but not actually that true. So the question is then become how to apply the best practice to this new ecosystem. The organization needs to rethink about how they view the capabilities in terms of the security control. The company needs to reevaluate and establish the context of the user and actions taken on their system. And the most importantly, business need to challenge themselves to the constant improvement that provide the necessary feedback loop to make the real changes. So this is actually the challenge. And now we proceed with the attack surface. How about that? We are seeing the massive expansion of the internet connected people, place, and things. And securing all of them is becoming a problem. The rate of internet connection is outpacing our ability to properly secure it. Organizations of all sizes from all sectors must come to terms of the growing number of reachable and exploitable vulnerability. We see that's growing here from the server to the cloud. We see that from insider threat up to the DDoS. Embracing the public cloud, for example, mobile and DevOps, and lead to expanding the attack surveys that challenge our existing approach to managing the threat and vulnerabilities. This is keywords. Let me share a few statistics, reflection of this slide diagram. So what we know from the World Wide Web, for example, is it's actually invented in 1989, but the first ever website went live in 1991. Today, there are more than 1.2 billion websites. We see the massive growth from the 1989, sorry. So first invented in 1989. There are about 3.8 billion internet users in 2017 only. 51% of the world population is 7 billion. Up to 2 billion increasement since compared with 2015. There are about 111 billion lines of software code being produced each year. and which introduced a massive number of vulnerabilities that can be exploited. And hundreds of thousands and possible millions of the people can now be hacked with their wirelessly connected and digitally monitored implantable device. We see that about their heart-based hacking, etc. This is a growing thing. Now we proceed to the industrialization of the hacking. This industrialization of hacking is a result of natural evolution, with the attacker launching the new type of the exploit with an increasing frequency, and defenders are quickly innovating to stay ahead with them. This is what we call the good one and the evil one. And then the motive and persistence of this hacker or the attackers have grown along with their understanding of the traditional security technology, their application, and how to exploit the gaps between them. As the IT environment has increased in complexity, exploits have grown in sophistication. We see that there is an APT on the right section of my screen. This is quite sophisticated recently. Moreover, with the significant money to be made, hacking has become more standardized, mechanized, and then profit-driven. We see from the last few breaches that happened in 2017, we're just wondering why they can monetize all the day-to-day breach. Some people say, some experts say, some of my friends say that it's highly possible they monetize that into the dark web. They're selling that aggregated of the data stolen from the many several breach that we experienced in 2017. They sell that on the black market, the dark web, for a sum of money. But before the year 2000, virus, we know, target mainly the operating system. A decade later came self-propagating worm, which moved from machine to machine via enterprise network. Spyware on rootkit, malicious software designed to gain the privileged access to computer and run shell T also emerged. Methods such as port and protocol hopping, encrypting, tunneling, dropper, sandboxing, evasion, blended threat, and techniques that use the social engineering demonstrate increasingly sophisticated ways to penetrate the network. We see that they're starting from the system into become a social engineering aspect. They challenge the knowledge for the end user. However, long before they execute an attack, hackers enter into the target organization IT infrastructure, conducting recognition using surveillance malware. So malware is actually part of the recognition process, and only when they know what they are up against, they do write a target-specific malware targeting specific department, perhaps, or application, or user, or even partners. To ensure the malware works, malware writers recreate an environment again to test it against the security tools. So in this case, what's an organization to do to protect itself? For starter, they need to accept the nature of modern network environments and device to understand how attacker thinks. We see the cloud recently, okay? And then they should assume that they are in state of persistent. They should assume, let me repeat that again. They should assume that they are in state of persistent infection requiring continuous response as they are moving away from what I said, reactive into becoming more predictive analytical. So this is quite critical. The mindset that previously when we have virus, worm, and spyware, we might thinking about the reactive. Something happened to our network, we give a response. But nowadays, you can no longer work that way. You have to create your own mechanism to protect your organization and create what I call predictive analysis. I think just a glance about it. And because of this, they also need to predictive security, give a response at any time. Let me show sharing about the 4 biggest data breach that happened in 2018. We have start from Adar. In January, the reporters from Tribune News Service say that he paid 500 rupees for login credential to a service being offered by anonymous seller over WhatsApp. Amazing. Using the service, the reporter could enter any other number as 12-digit unique identifier assigned to every Indian citizen. Doing so, they would retrieve a numerous type of information of the queried citizen stored by Unique Identification Authority of India. And those bits of data include name, address, photo, phone number, and email address. An additional payment of 300 rupees to the seller yielded access to software to which anyone could print to print an ID card for any other number. The data breach is believed to have compromised the personal information of 1.1 billion citizens registered in India, according to my source. Second is about Exactis. Security researchers discovered in June 2018 that Exactis, a marketing and data aggregation firm based in Florida, had left a database exposed on a publicly accessible server. This is related to the serverless architecture. The database contained 2 terabytes of information that include the personal details of hundreds of millions of Americans and business. Amazing. As when I write this, the executive has not confirmed the exact number of people affected to the breach. But he also, according to Troya, another source, that he said that he was able to find close about 340 million individual records. But he also confirmed that to the Wired magazine that the incident exposed affected customer email address, physical address, phone number, host, and blah, blah, blah. Okay, and other personal information. So we're talking about, from these last 2 cases, we're talking about PII, personal identifiable information. And Under Armour recently, what happened on 21st March, Under Armour learned that someone has gained an unauthorized access to their fitness application, a platform which is tracking a user diet and exercise. CNBC, for example, have reported at the time of the criminal responsible for the breach access individual username, email, and hash password. Hash password, it's not plain text, but it is possible to convert it back, according to some research. The incident did not expose user payment information, fortunately, as the Under Armour processed this data separately, nor did not compromise the social security number or driver license number, as the apparel manufacturer recently happened. And upwards of 150 million MyFitnessPal users are believed to have had their information compromised and data breach. The fourth is actually a lot more critical. It's MyHeritage. MyHeritage is, I create an article I published somewhere in the blog telling about the MyHeritage. It's quite critical from my perspective. Security researchers reach out the CIO for the MyHeritage at June 4th of June, revealed that they have found a file labeled MyHeritage on a private server outside of the company. And upon inspection of the file, the official at the MyHeritage determined that the asset contained the email address of all users who had signed up with MyHeritage prior to 26th October of 2017. So 2017. According to a statement from MyHeritage, they say that it also contained the hash password, but not the payment information, as MyHeritage relied on third-party permits. I'm just wondering if your password is breached, if your social number is breached, if people stole that, you know that that's easy for you to change back again. But how about if they take over your DNA information? We will not be able to change our DNA information. So this is 4 cases, and this one is highly related with the serverless application. Serverless architecture, about the GitHub. GitHub on the Gentoo Linux. This is my article published on the peer list as well, as I mentioned. As mentioned this article, at the time that I wrote this, the attack vector used by the hacker to gain access to Gentoo GitHub account, or how long the threat actors were able to do it, without being caught is still under investigation. It's not yet clear. This is usually happen. And what the breach happened to the GitHub account is not the first time that has led to difficulty. Recall the breach occurred to Syscoin. That's a cryptocurrency team account, and it ingested the official application with the malware. So you see that on this case, the threat actor is changing their behavior. They are no longer concerned about giving a massive attack. Instead of one by one, they planted the malicious system into each and every application available on the cloud, and they start to mining the benefit from it. And the Gentoo development team, this case is advising the user who previously downloaded and installed the material from the Gentoo via GitHub for potentially bringing the malicious code to redo everything from the scratch. So they have to delete and reinstall everything. Fortunately for this case, according to the Gentoo team, they say that the source, the original source from the Gentoo Linux is safely kept on their data center separately from the GitHub, and they say that the GitHub is just another copy. And this is something makes me afraid as well. A recent news mentioning there is about 3,046 mobile applications. It's leaking about 100 million records from 113 gigabyte Google Firebase database. Well, this case is as mentioned also in this article, and after applying this threat model to over 2.7 million Android, one of the research company found out there are about 3,046 applications for potential breach. Just because of what? Just because of they forget about putting additional security layer, such as, for example, this is Firebase is a backend as a service. When people trying to reach the database, normally they put a file name behind, but if they put nothing, but instead of just put a JSON, it will showing all the data inside. Amazing. Google already sent awareness to the programmer, but not every one of them aware about this implication. And this actually similar attack vector was happening. If we look at what happened to Hospital Gown at 2017, same thing. The improper authentication, the backend security setup caused a massive leak. This is for about 113 gigabytes of data for more than 3,046. 2,446, or about 80%, is actually coming from the Android, while 600 or 19.7, or we can say 20%, is coming from the iOS. It's not, I mean, it's affected to all, not just one simple operating system. Okay, so we go further and deep into what we call about the serverless. Serverless, by the name, people can say that serverless is mean that you don't have the server. No, that's wrong. So let me describe this a bit. Serverless is actually blurring the line between the various technical roles commonly being involved in the software delivery, where traditional architect, developer, and tester, and including the database administrator, operation, and security engineer, would collaborating to become one number. They become a cloud engineer. So everybody have the same title now. They're consolidating. Interestingly, the serverless computing is changing the way the software systems are being built and operate. Despite of being relatively new in the area within the IT industry, serverless has the potential to massively alter the way that the business value is being delivered. So we're talking about the business value being delivered with the software. It allows the running workloads that are available and scalable very cheaply. You can see the icon there at the bottom. Scalable and very cheaply, which is ideal for many product types and the business use case. I emphasize the three things: the scalable, the affordability, and the focus what I made the most. What actually before this, the developer thinking before they start to working with the program, they're thinking about what the hardware they might need, where to put that, etc. Now they just need to write the code and put it on the cloud. The serverless computing brings another revolutionary change compared to what we call the infrastructure as a service computing model. And that's the pricing model based on paying for individual function invocation rather than having to pay for keeping the server up. So we are not going to pay for keeping the server up. So we pay only for what we say that function invocation. Once the function is being triggered, it's up and it's calculated based on the function uptime. Then the organization using the public cloud are used to treating the cloud infrastructure cost as OPEX, operational expenditure, rather than CAPEX. But with an infrastructure as a service computing, they quite often still end up with making substantial upfront investment. So this is still challenging for some organizations. But with the serverless computing, this is usually no longer possible or cost effective, as it's much cheaper to just pay for function invocation made than to keep the server running all the time. My friend said that's okay. You put the 4 or 5 PM at the cloud, okay. But the question is whether you have a user or not. You have to pay for that. But for serverless, no. They only have to pay for every invocation, every trigger has been made into the function. In short, the serverless not only embrace the DevOps, the culture that has pure form of the DevOps in its DNA. So we call that the cloud computing infrastructure as a service. We call that it's actually a DevOps, but serverless architecture is already built in the DevOps into their DNA. And then the second thing is serverless makes operability a first class of concern and embed it into development process. So it is quite interesting. In the future, many of IT specialists will be replaced. Well, this is prediction, but in the future, many researchers say that the IT specialist will be replaced by broadly skilled of a cloud engineer. So it's emerging. It is merging. And it's consolidating between the developer and the cloud engineer. Interesting. Serverless, it will change the culture of the IT organization and impact on how companies use the cloud computing. So let's emphasize about 3 things in here about the scalability, about the portability, and focus what the matter most. So now we can say in the serverless architecture that developer is actually a cloud engineer as well. Okay. Many people say that serverless architecture is actually only function as a service. But for me, what I found is actually a combination between the function as a service and backend as a service. When we're talking about the function as a service, it's actually a product that has a piece of a business logic, a small footprint, like sending an email, maybe cropping an image or something, and it's very well suited to build an event-driven architecture. So just event-driven. Event-driven means when you trigger, the function work. When you are not triggered, it's just silence and just to take a nap to sleep. And one of the joy of this function as a service is that, as I put earlier in this article in this presentation slide, said that horizontal scaling, scalability in the previous slide, horizontal scaling is completely automatic, elastic and managed by the provider. So you don't have to be worried about the processor, you don't have to be worried about the memory, etc. And the biggest benefit is you only pay for the compute that you need. I put a link in here on the bottom of the slide about the economic analysis. It's a very good journal. This is a university journal about the economic factor analysis for serverless architecture. And then we proceed with the backend as a service. Backend is actually like a DB hosting. It's highly available backend that can be set up barely with any configuration and can scale almost infinitely. So the challenge of every database is about how big the storage is. This is completely scalable, so you don't have to be worried. Once it's created, the developer can focus on deploying the code and data only. We see from these two, actually the best of breed that provided by the serverless architecture is the way they can help and create an easiness for any developer to put the system on the web or on the cloud, make it accessible by the customer. This is just a sample of the concept about the serverless architecture. Especially, I just want to emphasize one thing about the serverless website. You see there, this is hosting can be offloaded to serverless computing, monitoring and managing the server takes time to be spent elsewhere. You don't have to be worried about how many users are visiting your website and about database warehousing. Traditional reporting, you mining the data, you put the data on database, you create a report, you create a trigger, you do the ETL. ETLs mean the extraction, transformation, and loading for records that you have on database. You have to concern about how big the process or how big the storage, blah, blah, blah. Now you don't have to think about that. So this is a general flow about what actually happened, showing the process from the end user up to the backend as a service. Some case may use backend as a service, some cases not. So I put everything this is in one slide. So this doesn't mean that you will have an exact situation or exact flow, exact pictures like what I'm giving on this slide. In a typical situation, the request from the application or the mobile application at the endpoint we see on the left side will reach through the API. The next stage is to trigger and execute the function and go through to function as a service. Fundamentally, function as a service is running back-end code without managing your server system or long-lived server application. This is just processing, because that is why I put the trigger there. You see the question exclamation mentioning the trigger. And now the request after the function as service, the request will goes to the backend as a service. This backend as a service will do the process and eventually return the data back to function as a service, and etc. until it's reaching the end user. So we see there's a blue line, we see the green line, we see the red line. The red line is mean some case the end user only reach a function as a service and then return back to the API to giving a result to the user. Some case the end user need to have the access to back end of the service. It's layered through the API, the function as a service, and then goes into the back end as a service. So this is the case. Now, talking about the threat, I would like to pick up OWASP framework about the application risk they are talking about in 2018. So I put the FIS and as a developer and operator. So this is actually previously when we do a development on a client server, we are not really care about the line of the code. But in serverless architecture, you cannot think that way. So you are now, as a security practitioner, evangelist, you must also worrying about what the developer put in their code. So this is about 10 things. This is the number of threats. Injection, for example, number 1, etc. Broken authentication. And then we back again with the previous slide. I'm showing 3 attack vectors here. This is what I say, that attack vector is the entrance of possible potential malicious activity can be done. So this screen or this image is actually showing an increasing of what I say that's a threat landscape, and also introducing new attack vector. Interestingly, instead of, we talked at the beginning about the default, we put everything in the center protect and with the one or multiple layer of the firewall. But this one, our data and our system is spread. We are no longer can think that way. So the concept of the firewall and your perimeter is now expanding. This is the uniqueness. This is the main concern when you want to use serverless architecture infrastructures. Let me simplify from what the OWASP previously have been given into my own experience. So I came up with 6 things related with the potential vulnerability. I will not saying on this presentation that this fixes you must be experienced. Depends on how you architecturing your cloud. So the challenge, instead of just based on the application, now your architecture is also being challenged. I will describe one by one, from number 1 to number 6, from what actually happened. But you can see on this slide, we have 3 attack vector came in from the API, from FaaS, function as a service, and from the back end as a service. Let me start with the process injection showing here. The process injection occurs when an application or malicious actor sends an untrusted data to an interpreter. What is interpreter there? API. Often the interpreter has its own domain-specific language. By using that language and inserting unsensitized data into the request to the interpreter, an attacker can alter the intent of the request and cause unexpected action. And perhaps most well-known and widespread injection flaw here is what we heard previously and many times is SQL injection flaw. This occurs when an input isn't properly sanitized and escaped, and the value are inserted in SQL statement directly. If the value themselves contain the SQL syntax statement, the database query engine executes those as such. So database doesn't care. Anything that comes through the SQL syntax, they will run it. And then the trigger action that were originally intended with potential dangerous consequences. This is the challenge. Additionally, consider any components of the custom request header. So your API, your gateway will also accept any request. So you must be aware about the other component, not just the HTTP request command, but also the other component of the custom request header that your application use as a parameter for database lookup. Beware about what you put there. Beware about what shouldn't be there. If your API requires 3 parameters, why this API suddenly calling 4 parameters? What the 4th parameter is about? And then, moreover, the malicious actor for this case are able to adapt to their toolset quickly to exploit the new vulnerability based on your API, and then launch a large-scale automated attack to detect the vulnerable system. We are not talking single threat actors. We're talking multiple and combine and aggregate at the same time, working in parallel to attack the vulnerability of your system. So there are 2 questions I would like to give. Maybe this will help. First, can you enforce a certain level of hygiene at the request level? So taking care of that context. Don't just depend to your web application firewall, but do your homework. Do clean up hygiene system on your request level. Are the HTTP request component that your application expect to exist or can operate without? Just put the least things, simplify things will be better. When you require 5 parameters, make it 3 if possible. If not, ya udah. Not enough, just proceed at it. And then the second question is, are you able to detect and recognize when your application is targeted with the unusual request pattern or high volume or simple DDoS? Do you have a system in place that can do that detection in automated fashion? Don't think to do it manually. The time is past. Are these systems capable of reacting and blocking to such unwanted traffic? This will be your last questions. Okay, now about what we call a broken authentication. This is actually a flaw in implementation of authentication and session management mechanism for the web application, which can lead to exposure of unwanted data, stolen credential or session, including the impersonation of legitimate user. Broadly said, the attackers rely on the vulnerabilities in the way endpoint to the cloud server communication is implemented, or they target how session or authorization token are generated, stored, transferred, reused, timeout, or invalidate by your application to obtain this credential. Again, this is not only about implementing the firewall or web application firewall, but it would be better when you can customize and create from your end. And after they obtain this credential, attacker impersonate legitimate user and make a request to your application using those tokens until your application put it on expire for the token. So the countermeasure for this maybe suiting for this threat. I'm gonna say this is just only one, maybe more, but what I found in exactly giving the solution is you need to establish identity access management. Most of the function as a service is stateless. It disregards the state connection. However, it doesn't matter when you are using stateless or session authentication. Both is fine. But the biggest problem is when you set a public read access for some or many other components important for your system. This will overlap. This will make your authentication mechanism less powerful. Okay, insecure environments and settings in here. We see that the communication is actually taking in an encrypted manner. So why we say that insecure for this case? Insecure means that depending on specific workload, for example, exposure of unauthorized data and manipulation of internal web application state could be happen because of the encryption less secure, such as when you are using hash or SHA, the attacker can use SHA polling perhaps for the attack. Another issue caused by insecure environment is a flaw commonly involve encryption process, again, that have been deficiently implemented. Some of the examples are the lack of encryption on the transported or stored sensitive data using the vulnerability legacy encryption ciphers, where the malicious parties can intercept and decode your data. We are talking about two things here: data in motion and data at rest. Two things, not just one. And although it is less commonly, there can be a flaw in application or the protocol implementation or the client browser, which can also lead to exposure of sensitive data. Exploit that ultimately lead to sensitive data exposure. The first gate was coming through your log. You see the Firebase error message that always appear when you do something wrong, and when the one application is not ready to be published and they found a bug, we put something there and showing Firebase error message. Just watch what's showing on that Firebase message is actually can lead you to potential attack. So again, to respond to this, you need to validate and provide sufficient encryption for your system in order to protect how the data is communicated. Just be careful when you implement the function as a service or either including backend as a service, you are not putting the data in one place. You are scattering the data in many places. You are transporting the data. So don't forget to secure and to protect in the way of doing the encryption with the sufficient encrypted for any data you transfer between the nodes, either that from the end user, from the function as a service, or from the backend as a service as a result. And this, we're talking about the over-privilege. This threat can happen at any level of your application stack. We are not talking about the administrator who create the login, but this is how the developer set the account privilege. And this can apply to the operating system, the middleware, the platform services, the web server software, application code, including the database layer of your application. Your application should properly check and restrict access to individual module, components, or function in accordance with the authorization and authentication scheme used by the application. Remember, implement the least privilege. The weaknesses sometimes a developer create a single permission for entirely function. This is a massive devastating damage that will happen if they still doing that way. And how to countermeasure, I mean, how to protect this. I can give a several example, but this is one thing that more makes sense. You should block access to the path to the administrative console. That's the first important thing. Second is you need to protect about access to the configuration or status page that are installed or enabled by default. So you need to be careful, check inside of your application since you are using so many third-party applications. You can host your function, your business logic into the function as a service. However, you need to make sure that environment where you put the data or which application that you are work with your data must be secure, very secure. And then this is about the cross-site scripting. The cross-site scripting is about the flow happen when a mobile web application includes the user provided data that is sent to the browser. What's the biggest problem on this? Many websites, they provide the HTML editor. They're allowing users to put a giving a comment, put everything there, but at the end, they're not able to sufficiently protect what the user put on their comments or on the HTML comment box. Resulted, the server has been successfully injected by malicious code. So this is moreover, people say that, hey, you can implement in protect this by the web application firewall. Is it okay lah? But in terms of it will be better when you can restrict all HTML editor input into your system. Or if you cannot, just remove all the HTML text within. It will lead or it will create a little bit more savior protection how the data get into your system. Okay, this is number 6, the last one. Actually, the last one that's a potential threat that will be experienced. You all see that I put the HTML there. That just to make it simple, the cross-site request forgery is an example. You create a form. Within that form, you asking for entering several fields. At the bottom, you will see the submit button. When user click that, all information in that field will be transferred to database for further action. Then in this case, the cross-site is actually, they are pretending like sending an information, but not through your original form. So in this case, the simplified CSRF case is actually mechanism actually that request sending a request to the browser. But the challenge from our side is we need to make sure that the request came from certain IP address or came from a user and user endpoint. It's actually a legitimate traffic. You see that from my HTML sample. I can just copy and paste that and then put it into my notepad and then try to attack using this. Maybe for some other website, it's easy. And to countermeasure that, what I did in personal, I create unpredictable token. Let's say you have 5 fields: number, name, password, date of birth, any field, 5 fields. 5 field, you're asking the user to key in the information. Now you create a second field, a randomized field name with randomized content. And then before you process the information entered into your database, you have to validate that the field, including and the value that we treat that as a token is actually legitimate. And then the last one is we implement what we know is a CAPTCHA. CAPTCHA is, we see many things from Google, many other websites. This is just only one to challenge. We will say this is only one to challenge whether this is human or robot, but for me, it's more over than that. It's actually challenging whether the traffic is cross-site request forgery or the legitimate one. Wrap up. We have been talking many things previously in the last, oh my God, time's taking so fast. Okay, let me wrap up with the summary. It says first and foremost, a serverless application eliminate the main source for successful exploit today. Yes, unpatched server. That's the key. Such server are binaries. What I mean in binary is security is a binary. Security, either you have it or you don't have it at all. So 0 and 1. We cannot say we have it less partial. We can have partially. No, there's no such a partial command. 0 or 1. Okay. While the serverless does not remove the need to keep your servers updated, it pushes this concern to the platform provider. So be careful, your platform provider, you should questioning that. Managing the server is one of the core competency for them. So likelihood the machine won't be up to date is quite low. So we better pray for that. And then denial of service attacks. Denial of service attacks work by preventing a server from servicing legitimate requests and repeating this attack until all servers that can fully a request is become unavailable. I say for serverless architecture, remember, you pay for every function trigger. Every function being triggered, you pay. So for me, I give a new definition, denial of wallet attack. So it means that many people have legitimate traffic attacking your function and you not validate that, it will create a surprise billing amount at the end of the period of the subscription. Beware of that. And just remember that DDoS is actually very, very critical in the serverless architecture. And then the vulnerability. Serverless takes most of the surround sound of your hands, which is remind you it's your own code, including its vulnerability. The vulnerability reside on the operating system, reside on the storage, reside every other place. Is actually a bit transformed into your code. Now your biggest concern is what vulnerability you invite under your code. Be careful with that. You may invite the cross-site scripting, SQL injection, or the last one, and the cross-site scripting form that I just presented. And you need to be careful of that. And also, the number 4 there is about dependency of the vulnerability application. It's now no longer become a fancy when you found something new on the internet, you start to download and put together with your application, even then on test area. We cannot guarantee that this application will not invite the future vulnerability. However, what my perception and my concept is, the narrow system you have, the better it will be. So I would like to limit myself in the way that I architecting the system into less application involved. So it's actually minimize my headache whenever every day I see there is a growing number of attacks or threats happening to so many applications. We will see gradually after this time, maybe 2019, that the attack is no longer focused on the node, but the attack is now starting to focus on how you for the application that use the dependency with the other application. And the last one is beware that your data address means that the data you store on the server is now equally accessible. Remember the case that I presented, the article that I presented about the Google Firebase 3046 application. The main reason why it happened is actually the developer put the data on the free database provided by Google called as a Firebase, but the developer did not aware there is a potential security breach, which is allowing the user who access the system to download, extract, or I don't know, even changing if necessary, if changing the data what's possible. So in closing up, by using serverless architecture, some companies think they are one step advanced. They are creating more capability and they are providing more flexibility. But at the same time, they are actually inviting the issue. They are inviting the threat. They are inviting the attack. This situation could result in potential damage for the company. We are seeing so many data breaches 2017, including 2018. The reason behind that is not because they don't have adequate security protection. They do. But the main issue is they are not continually, persistently monitoring what happened inside of their network. My experience, it is more difficult to manage what is unmanaged instead of you manage what you have it right now. Many administrators, I say that, do you know how many servers you have on your company? They may mention that any numbers, which is exactly right. But when I ask how many nodes, how many endpoints, how many users that connect to your system right now, they cannot give the exact number. My concern is maybe several of those connected user, which is they thought at the beginning is a legitimate user, it's actually a malicious attacker. So be more vigilant in this case. That will be all attendees. I put back again to Easy Council. Let me sip of water first because I'm quite thirsty. I'm open for questions. Please, thank you.